Hi again, it's Rob from Pathway Connectivity Solutions, and you've seen me do some work here before in my lab where you know I have a lot of gear. Well, today I'm going to do something really cool with an eLink that I never thought I would ever use an eLink for. Now, you've seen me talk about an eLink and how it's used on the big shows like Super Bowl halftime to separate the production rig from the venue rig, and it's being used more and more on Broadway shows to separate out different parts of the network to different departments. So let me show you in my little lab here, my little eLink that is going to be the main star of our show today. And then right now I have a Cognito here that's showing a little rainbow effect, which you'll see is being played through my network of switches all around here. And it goes into my back rack where I have lots of vias. And then it comes up top where I have a whole bunch of other gear. Almost everything we make is represented on this back wall here. Repeaters and path ports and, oh look, there's something that is going to also star in our show. This is a Pharos LPC, and this is what I use to control the lights on Niagara Falls. And that is what I'm going to show you today on some of our test tiles that I have on my back wall here. Now, what am I going to do with them? Well, stay tuned and I'll show you. There's a link in the description of an entire video that describes the lighting of Niagara Falls with the lighting control system. The main controller being the Pharos controller. The network is Pathway Connectivity Solutions with fiber and path ports and vias to get the data around, and 6i to do remote management. So here's a shot of the American Falls, and what you can see when I turn the camera around here is an array of lights. There's 3 positions of these, and in total there are 1,400 of these individual red, green, blue, and emitters. So that's 1,400 DMX channels. And how am I going to get that on my back wall? That's what this video is about, and that's what eLink is going to help us do. So at the falls, we have 1,400 individual LEDs. But on our wall, we only have a couple dozen. And these are RGBs, not RGBWs. So how are we going to get one to represent the other? Think. If a red channel comes up at the falls, we'll just emit the red LED here, and the green will go to the green, and the blue will go to the blue. But with 3 colors, how do you make white? Well, we know that if you bring up red, green, and blue, you do get white. So whenever the white channel at the fall comes up, we'll just push all 3 channels to full. Now, to make all of these pretty colors at the falls, there's a lot of data coming. And DMX comes at 40 hertz, and there's 1,400 channels. And on our lambda tiles, I only have red, green, blue, red, green, blue, red, green, blue, red, green, blue across the top. That's 12, and I've got 4 rows of that. So times 12 is 48 DMX slots, and I have 1, 2, 3, 4 tiles. So I only have 192 DMX slots to represent 1,400. So this is my designer software here, and this is a representation of the American Falls and the Canadian Falls with all of the different RGBW type fixtures. So if I select one of them here, I can actually see that this is not an RGBW, but it is a BRGW, and its console address is 525, which is obviously in the second universe, and its console fixture number 553. So I put a new background over top of my white fixtures, and the red fixtures are now representing pixels on my wall. So I have 1, 2, 3, 4, 5, 6, 7, 8 across by 4 for the American Falls, and similarly on the Canadian Falls, I have the 3rd and 4th lambda tiles, so that would be 9 through 16. If I zoom in and I select this fixture, which is console fixture 536, I'm going to use pixel 60 on my wall. So what I do is I take that console address of 773, and I've made this Excel spreadsheet that has a bunch of clever equations. But if I put in the absolute address for lambda fixture number 60 and I type in 773, and I choose from my fixture types, I've got my WGBR and my BRGW and my RBWG type fixtures, and I choose the right one here, and over here it is an RB, so I'll just check RB BWG, and then this little equation over here will actually find the offset of the R, the G, the B, and the W, and it will put them into the appropriate cells. So the red is the first, so it's 773, and the green is the fourth, so it's 776. The blue is the second, so it's 774. And to get the white, we actually take the third value, so 773, 774, 775, the third value, and we would bring up on 775 all red, green, and blue. And then I have a macro that copies that to the proper export format that the eLink can consume. So if we look down to slots 1, 7, 8 on the export, which would be down here, these are the values that we just input for the output patch of slot 178, 179, and 180. Now, for many reasons, I want my Lambda tiles just to listen to one universe, and it happens to be universe 5 in this rig, but I take that one universe from all kinds of different path ports. So it might come out of this rack mount path port to go to one tile, and it might come out of this DIN mount path port to go to another tile, and it might come out of this wall mount 2 port to go to the third tile, and then another one I might run through our DMExit emergency controller to come up and run the fourth tile, because I like just testing all kinds of things with this controller here, or maybe this controller here, and I have a vignette controller here. So it'd be inconvenient for me to have these Lambda tiles listening to some sort of weird patch. It would just be great if they were always listening to the same universe they listen to every day for my testing. So let's open up Pathscape here so we can configure the eLink with all the hard work that Excel has done for us. So this is all the devices on my network. I'm going to find the eLink, select the eLink, and we will see that this eLink is set up to receive SACN, and it's actually going to transmit SACN. It's going to receive it on the primary port, and of course it's going to transmit it out the primary and the secondary port here. I could just pick the secondary, but I want to just send it back onto the same network it came from. Now we have to do the clever patching. So we open up its children. There's 16 different paths to choose from. I only need one. So the receive patch is configured at 1. Well, that's not very interesting because we know that the falls use 3 universes. We just did all of that number crunching. But we do know that it's going to transmit to where the Lambda tiles are expecting it through all my path ports. So we'll make the transmit universe 5. Now this is the magic here. So we go into the custom universe editor and we're going to make a new custom universe. And for this, I need to go into the advanced editor and I'm going to call this the Lambda patch. And rather than doing typing in here, I can just right click in here and choose import comma separated values. And I will choose the Excel export that we just did. And it does all of this lovely typing for me. I'm just going to save this and close. And then I'm going to select and close. And then the receive patch will be the Lambda patch. And then we can see that on this path, the network DMX is actively receiving and it is actively transmitting. Now let's have a little fun here. I've opened up Pharaoh's Designer. And I'm doing some live transmission to it now. So if I select all of my red, green, blue fixtures, red, green, blue, white fixtures of the various types that you know are crisscrossed all over 1,400 DMX channels, I have them now going through the eLink onto the Lambda tiles. And if we create a new scene here, let's see if we can make these all red. Oh, isn't that pretty? They're all blue, and we can go into direct control here. Let's take the blue out, bring up the green, and then the magic white channel, which is all of them. Look at that. So now, no red, no green, no blue, just white, and we get white light. We could actually just take this middle row of the American Falls, and let's make them yellow. Now remember, the left two tiles are the American Falls representation, and the right two tiles are the Canadian Falls representation. So let's take a swath right in the middle of this, and let's make them, let's say they're green. Now, after all this crazy Excel spreadsheet and all the rest of it explaining how 1400 can go down to 192 and RGBW in every single combination can go down to simple RGB, I am going to sit back and let you watch a very short little clip that I programmed for Monday Night Football on ESPN. And this little eLink here with its very simple one cable in the back is going to do all the work. So I'm going to rearrange the screens. You're going to see the Pharos Designer software running. You're going to see the Lambda tiles, just 192 of them on the wall there, or just 64 of them in fact. And you will see live footage that I shot down at the falls when we tape this. So I'd love to hear if you had really cool things that you've done with eLink or things that you could imagine it could do for you. So till next time.